The Salisbury Plain is a landscape defined by wind and sky, a vast, open expanse of chalk grassland where the horizon seems to stretch endlessly into the memory of time. 5,000 years ago, this place was not the empty, silent pasture we see today, but the throbbing heart of a transformed world. It was the Neolithic period, the final chapter of the Stone Age, a time when humanity was teetering on the precipice of discovery, learning to tame the earth while still fearing the heavens. The air here, thick with the scent of damp earth and wood smoke, vibrated with a sound that had never been heard before, the rhythmic, collective groan of hundreds of human voices pushing against the limits of what was believed possible. In the center of this immense human amphitheater stood the object of their obsession, a colossal, jagged block of sarsen sandstone, weighing 25 tons. It lay on the ground, a sleeping giant hewn from the living rock of the Marlborough Downs, waiting to be coaxed into a vertical position that would defy gravity and define a civilization. This is the story of raising Stonehenge, of how 25-ton stones were moved without metal, a feat of engineering so audacious it strains the modern imagination, achieved not by slaves or machines, but by a community united by faith, ingenuity, and an unyielding desire to touch the divine. To understand the magnitude of this achievement, we must first strip away the modern world and immerse ourselves in theirs. Imagine a Britain covered in dense, ancient forests, where wolves still prowled beneath the canopies of massive oaks and yews. The people living here were not primitive in the sense of lacking intelligence. They were master botanists, astronomers, and architects whose only materials were those provided by the natural world. There were no iron chisels to shape the stone, no steel cranes to lift it, and no wheels to transport it. Metal was entirely absent from their toolkit. The hardest substance they possessed was not iron, but stone flint, obsidian, and other types of rock that could be chipped and knapped into razor-sharp edges. Yet, faced with the challenge of building a monument that would align with the solstices and stand for eternity, they did not see obstacles. They saw a puzzle to be solved with wood, rope, and bone. The journey began not at the construction site, but in the quarries located nearly 20 miles to the north. Here, the great sarsen stones lay scattered across the landscape, natural boulders created by the silting up of a vast, ancient seabed. These were not loose stones to be picked up. They were embedded deep into the chalk earth, stubborn and immense. The first task for the Neolithic builders was extraction. Without metal drills or explosives, the process was one of patience and endurance. Using large, fist-sized stones known as hammerstones, they began to pound the bedrock around the boulders. It was a deafening, percussive sound that must have echoed for miles, a rhythmic drumbeat of industry. They created channels in the rock, hammering until they could drive wooden wedges into the cracks. Then, employing a technique that bordered on alchemy, they poured water onto these wooden wedges. As the wood absorbed the water, it expanded, generating an immense, slow-growing pressure that cracked the massive sarsen free from its earthly tether. This was the first step in raising Stonehenge, freeing the giant. Once a stone was liberated, it had to be prepared. They wanted these monoliths to be smooth and rectangular, a sharp contrast to the natural, rugged world around them. Using stone axes made from durable flint, laborers began to dress the stones. They pecked and ground away the rough surface, flattening the sides with a precision that is difficult to replicate even today. The grooves left by their flint tools can still be seen on the stones today, thousands of years later, fossilized fingerprints of a vanished workforce. As the stone took shape, the logistics of moving a 25-ton object across rolling hills, dense woodlands, and river valleys began to take shape in the minds of the architects. The engineering principle they relied on was simple, yet brutally effective: friction reduction and leverage. They did not attempt to drag the stone directly across the ground. The friction would have been insurmountable. Instead, they turned to the forest for assistance. Massive oak trees were felled, stripped of their branches, and cut into roughly equal lengths to serve as rollers. But before the rollers could be laid, a trackway had to be prepared. Archaeological evidence suggests they built temporary roads made of wooden planks, similar to a railway track, laid directly on the ground. This served two purposes. It provided a hard, flat surface to prevent the heavy rollers from sinking into the soft chalk or mud, and it created a stable corridor for the movement. The stone was then levered onto a wooden sledge, a raft-like platform made of massive timbers, lashed together with cords made from lime bark or animal hide. The sledge sat atop the wooden rollers. Now, the physics of the operation took over. To move 25 tons, sheer strength was not enough. It required synchronization. A team of up to 200 people, men, women, and perhaps even older children gathered around the sledge. Ropes made from twisted plant fibers, rough and biting against the skin, were attached to the sledge. On a signal, perhaps a drum beat or a chant, the pulling began. The ropes grew taut, muscles strained, and the immense weight shuddered. Slowly, agonizingly, the sledge slid forward over the first roller. But this was not a continuous motion. As the sledge moved forward, the roller at the back was left exposed. To keep the stone moving, a team of rollers had to run to the back, frantically lifting the heavy log and carrying it to the front, placing it down ahead of the sledge, just in time for the stone to roll over it again. It was a perpetual cycle of lifting, placing, and pulling, a ballet of heavy industry performed in slow motion. Every yard gained was a battle won. The physical toll on the bodies was immense. Shoulders dislocated, hands were raw, and exhaustion was a constant companion. But the spiritual or social imperative to move the stone must have provided a reservoir of strength that transcended physical pain. They were not just moving a rock, they were moving the world. The route from the Marlborough Downs to Stonehenge was not a straight line, and it involved traversing difficult terrain. Recent theories suggest they may have utilized the natural contours of the land, and perhaps even waterways, for part of the journey. The weight of a 25-ton sarsen stone is equivalent to about 4 fully grown adult elephants, or 3 large double-decker buses. Imagine floating such an object down a river. They likely built large rafts or dugout canoes, lashing them together to form a pontoon. The stone, on its sledge, was maneuvered onto the raft. The buoyancy of the water relieved the strain on the rollers and the pullers, allowing the river to do much of the work. Steering such a heavy vessel through currents would have required its own form of mastery, using long poles and paddles to navigate the drift. However, they arrived at the site, whether by land or water. The final approach onto the Salisbury Plain would have required the overland sledge and roller method once again, dragging the massive megaliths into position for the most critical phase of the construction, the raising. This is where the mystery of Stonehenge deepens. How do you take a stone the size of a double-decker bus and stand it upright without a crane? This is the raising Stonehenge moment, the pinnacle of Neolithic engineering. The builders did not lift the stones from the top. They lifted them from the bottom. The key was the center of gravity. To raise a 25-ton monolith, they first had to prepare its final resting place. They dug a deep, sturdy pit into the chalk bedrock, using antler pick-sharp, durable tools made from red deer antlers that could break through the soil with surprising efficiency. This pit would house the base of the stone, anchoring it against the wind and the pull of gravity. Next to the pit, they built a massive earthen ramp, a sloping incline leading up to the edge of the hole. As the stone moved higher, the center of gravity shifted. If the stone tipped too early, it could crush the workers or fall into the hole at the wrong angle. To control this descent, they used heavy wooden A-frames, primitive cranes known as shear legs. As the stone was pulled up the ramp, the teams holding the safety ropes on the other side of the A-frame played out their lines slowly, acting as a brake. The angle of the ramp was calculated precisely so that as the stone reached the top, it would tip slowly, guided by the ropes into the pit. There was a thunderous thud as 25 tons of sandstone met the bottom of the hole. Dust rose in a cloud. The crowd held its breath, but the stone was not yet standing. It was likely tilted at an angle, resting against the side of the ramp. Now, the true power of the lever came into play. Teams of workers used long, sturdy timber poles as levers, jamming them under the top of the stone and pushing down with their combined body weight. Inch by inch, the stone rose, its base pivoting in the hole. They repeated this process over and over, raising the great circle of sarsens, 30 uprights in total, each one a testament to patience and physics. To do this, they capped the uprights with massive horizontal lintels, locking the stones together like a giant set of Lego bricks. On the underside of each lintel, they carved corresponding holes or mortises. The lintels were dragged up these ramps and then maneuvered sideways until they dropped into place, the tenons clicking into the mortises with seismic finality. The construction of Stonehenge was not a single event that happened in a year. They passed down the plans, the techniques, and the sacred knowledge to their children and grandchildren. But why? Why go to such extraordinary lengths to move these monstrous stones without the aid of metal or modern machinery? The answer lies in the alignment. The entire structure is oriented toward the solstices. On the summer solstice, the sun rises directly over the heel stone, bathing the altar in the center of the circle with light. The act of moving these stones was an act of worship. The stones themselves were not just rocks. They were ancestors, eternal entities watching over the living. By shaping the earth and the stone, they were imposing order on chaos, creating a mirror on the ground of the perfection they saw in the sky. As the centuries passed, the landscape around Stonehenge changed. The site fell into ruin, the great lintels crashing down in the storms of ages past, the uprights leaning wearily like tired old men. Myths and legends sprang up to explain the impossible feat. These stories were born because, to the medieval and later minds, the idea that humans could have moved such masses with wood and rope was simply unbelievable. Yet today, through experimental archaeology, we have proven that our ancestors were not magicians, but master engineers. Modern teams have replicated these techniques, pulling multi-ton stones using wooden sledges and rollers, raising them using levers and A-frames. It works. This realization makes the story of Stonehenge even more powerful. It strips away the mystical veil and reveals something far more inspiring: the capability of the human spirit when driven by a shared purpose. They did not have the wheel, the arch, or the iron nail, but what they lacked in technology, they made up for in observation, patience, and social cohesion. Standing on the plain today, looking at the weathered remains of the great trilithons, we are not just looking at a pile of rocks. We are looking at the fingerprints of our ancestors. We are seeing the result of thousands of hands working in unison, driven by a desire to leave a mark that would outlast their fleeting lives. They stand as a testament to what can be achieved when human ingenuity is pushed to its absolute limit. They challenge us to look at our own world with all our advanced technology and ask if we possess the same dedication, the same community spirit, and the same vision to build something that will still be standing 5,000 years from now.